to compare the risk characteristics of three companies, and you'll see that no two lines of business are the same, correlations are not the same, risk diversification credit is different, risk capital allocation is different, and so on. So we're going to look at three companies: Berkshire Hathaway, Hartford, Swiss Re. Let's open each one of the composite TGs. We then, I guess, run our model with each. This is good for Swiss Re, good for Hartford, and Berkshire Hathaway, it's good new. Well, let's suppose to just compare quickly the model displays. Well, let's see. The accident year trends are different. The runoff for HOFO is pretty similar. Okay, and each one has a 0 calendar year trend, but process variability is different for each. It's particular specific to that mix of business. If you now compare PPA, but they're not in the same order here, that's unfortunate. Well, they all look different. I mean, changing trends versus one trend versus 0 trend. They're all different. Okay, let's do a forecast for each. So each line of business. And I think I might have looked at an example where I actually looked at correlations and show you that correlations are different. If you look at the correlations here, I would have to open all three. Well, anyway, this is Berkshire Hathaway, is it? Can't remember. This is Berkshire Hathaway. If I run Berkshire Hathaway twice, now Swiss Re, HF, Berkshire Hathaway. Okay. You can't open the three windows all at the same time. I mean, I can open Berkshire Hathaway and just show you that HO and FO, PPA are 0, and there's one cluster here, WCCMP. If you now open Swiss Re, well, HFO is correlated to SL, but it's not the case in for Berkshire Hathaway. So now let's do a forecast for each. We load good combined here. Load good combined there. And then load good new combined. Open the three forecasting summaries. Let's now look at LOB comparisons, LOB comparisons, LOB comparisons. Well, let's see. Now, for Hartford, WC is a big proportion of its reserves, whereas for the Swiss Re, it's OEB. It's also OEB actually for Berkshire Hathaway. If you look at PPA, it must be in others here for Swiss Re. You can tell that's SR, BH, the labels are on the top, HF, top bar, and so on. Why don't we look at summary by data sets and accident years, accident years, accident years, and just check out the coefficient of variations. It's 9%. Could have done that in the graphs. 9%. And Hartford will be much less, 4%. Let's go back to LOB comparisons, and we can check out the coefficient of variations. Excuse me. LOB comparisons. coefficient of variations. Okay. For instance, international for Hartford's got a large coefficient of variation. For Swiss Re, the largest coefficient of variation is PL, public liability occurrence. What about OEA? OEA is 29%, whereas for it's 41%. It's a big difference, 41% versus 29%. So they are different in a lot of respects, coefficient of variations. What about if we look at calendar year streams for the aggregate calendar year streams? Let's choose 2012. So by 2012, Berkshire Hathaway pays 90% of its payments. 90% of its reserves are in the first 5 years. For Swiss Re, it's 84%. For Hartford, it's 78%. So a big difference between 78% and the 90% for. What about if we look at the risk capital allocation by calendar year as a total? Well, you get very different profiles. Very different profiles between Berkshire Hathaway, Swiss Re, and it's also very different profiles for, let's suppose we look at workers' comp by calendar year. Define workers' comp, don't I? Workers' comp. Okay. That's risk capital allocation, workers' comp. If you look at the summary by calendar year, just for workers' comp, you can see that by 2012, 64%, 2012, 67%, 2012, 66%. Okay, actually, in terms of workers' comp, they're very similar. If you look at OLOC, is that here? OLOCC. Is that here? OLWC. And here, do we have OL? Okay, let's look at that one. 2012, you've made about 70% of the total reserves are paid within 5 years. 89%, that's very different. 90%. Okay, so Swiss Re is a little bit more like Berkshire Hathaway, but not in terms of risk capital allocation. If you look at the risk capital allocation across the aggregate, in terms of percentages, risk capital allocation, summary data sets. Let's look at this one. Oops. Aggregate, summary by data sets, risk capital allocation, and aggregate, summary by data sets, risk capital allocation. So for instance, for Hartford, 48% of the risk capital allocation is to workers' comp. Workers' comp, as far as Swiss Re is concerned, 12.97%, and for Berkshire, it's fine. Then you want to look at also the risk capital allocations, a percentage of the mean. That means you've got to do a simulation for each. Let's just quickly do that for fun. But we'll just look at the reserve and we can do this for the combined reserve. Incidentally, those tables that we have here, we have forecast summaries for reserves, combined, reserve and underwriting, which is the same as the next future accident year. Reserve, 1,000. Reserve, 1,000. So we just want to look at workers' comp as a percentage of the mean in terms of risk capital. A couple of graphs. That one at 95%. This couple of graphs, 95%. that one. Risk capital graphs, 95% this one. Workers' comp is 7.84% here. That's Hartford, 21% for Swiss Re, and workers' comp here is 22%. So in terms of risk capital, okay, it's interesting, they're very similar. But what about REA? REA here is 54%. REA there is 14% only. Big difference. And REA here, well, so very small proportion of the mean for which you need you actually need risk capital. So you know the companies are in fact different, and each one has to be modeled on its own. There's no, so it's not like one glove fits all, and that's very important. Trend structures are different, correlations are different, process variability is in fact different. Okay, why don't we, I mean the other thing one can look at is how in terms of just something to do with means. Let me just check. So I guess what you see here, if you look at workers' comp, for example, then for Berkshire Hathaway, the percentage of risk capital as a percentage of the mean is 22%. For SR Swiss Re, it's 21%, just a little bit less. But for Hartford, it's a much smaller proportion of the risk capital. Whereas if you look at something like REA, then Berkshire Hathaway is very large. Swiss Re is much smaller, and REA, Hartford is very small. And then you can look at the corresponding coefficient of variations for these three companies. So if you look at workers' comp coefficient of variation for is very large, and of course it needs a lot of risk capital as a percentage of the mean. If you look at SR, well, the coefficient of variation is less than it is for Berkshire Hathaway, but it's still a pretty large coefficient of variation. And we risk capital at 95 percentile, we only need about 14% of the mean. Whereas for Hartford, it's tiny, it's only 6% coefficient of variation. And there you also need a very small proportion of the mean. Okay, so the next thing I just want to do is what's called updating. So I'm going to close Swiss Re. I'm going to close Hartford, and I'm going to, in fact, why don't I just close all the triangle groups? That would be probably easier. I'm just going to go to Berkshire Hathaway, and suppose 1 year has passed and you've got an additional diagonal worth of data. That additional data can be imported automatically using comp scripts and into the system, and then the whole composite triangle group updated automatically. But let's do it manually, and the only part I'm not going to do manually is feeding the additional data. So you go to BH and you expand. So I'm going to expand the composite, and it'll become 1, and obviously you expand all the basic triangle groups, each line of business, which is contained in the composite. And let's do that. I'm only going to expand it 1 year. And now let's open both of them. So this makes the monitoring and the updating so easy. It's effortless because once you have a model at year in 2007, you don't have to design new models at 2008. You have everything already. So, I mean, the past is not going to change. Any sort of calendar year changes that occurred 3 or 4 years ago are still going to be there 1 year later. So let's tile these vertically and open Good New. You notice that we also have a Good New in the updated composite, but the updated triangles do not have an additional diagonal. Actually, we were doing this at the end of 2006. So what do we have for them? Oh, 2 of them. Okay. Now, if you open the residuals, well, actually, if you look at the parameter estimates, they're all the same, because the additional diagonal that we added doesn't have any data in it. So if we look at the residuals, they'll be identical, except for one of them will contain the additional calendar year. Okay, there's our 07 here. All right, so that's all that's involved in updating, because it's effort, and all that could be automated. Of course, if the residuals for a particular line like workers' comp, when you add the next year, sit really high or really low, something must have changed. Otherwise, nothing has changed. Okay, thank you.